There are currently a wide variety of life cycle cost estimation tools available for building projects. In this presentation, you will discover the support tools that can help your organization identify the inherent limitations, strengths, and weaknesses of these tools, and evaluate their suitability for different types of capital projects. Here to present their findings, please welcome Derek Ross, Mike Bellamy, and Robert Ries.
Good morning, everyone. We're here this morning to present out on a short-term research project sponsored by the Facilities and Healthcare Sector Committee. But the real reason we're presenting here today is that we're presenting on a core topic of value, and that's specifically life cycle value. Facility life cycle cost, broadly defined, is a research imperative or a burning platform of the Facilities and Healthcare Sector Committee. Previous research sponsored by the committee pinpointed some missing pieces, specifically what resources are currently available for life cycle cost. Can we identify the gaps in research needs going forward? So fundamentally, the research is about optimizing value, a topic we're all committed to regardless of facility or project type. Life cycle value analysis is a key strategic process that leads to superior performance. The overall view that we took for life cycle cost analysis is the triple bottom line. So conventional economic analysis is the foundation, but we also recognize that facilities directly and indirectly can affect their occupants' performance, comfort, and well-being. And optimizing environmental performance may be critical for some organizations, as well as impact the bottom line. So the research scope is the facility life cycle. It includes the triple bottom line, and we classify resources for life cycle cost in terms of standards, guidelines, data sources, and tools. Are these resources available to us today? So our goals and objectives, simply put, were to identify those existing resources, identify the gaps and barriers to the use of life cycle value analysis in practice today. So what did we find? We found that resources available today are primarily economic, particularly in terms of the standards. Some resources exist in occupant and environmental perspectives, and no resources encompassed all of the triple bottom line. All the details on the available resources and the conclusions of the research can be found in our report.
Good morning. When was the last time you had to purchase a light bulb? Strange question, but everybody has to do that. As you can see, there's so many choices. How do you make the decision to spend your hard-earned money for a six-pack of discount bulbs that might last for a couple of weeks? Spend $10 for that bulb that'll last for 13 years, guaranteed. That's why we want to invite you to this research team to understand a way to make those decisions, how to make your investments, whether you spend it in your capital plan or make it later for your maintenance budget. That light bulb can make the difference between increased productivity and developing that safe, productive workspace that we all covet. Think about what that does to your business plan. At the Smithsonian, we do that most of the time in our iconic buildings. The rental center was Clara Barton's hospital during the Civil War. The Smithsonian Castle, built in 1855, and our research installations are instrumental in scientific discoveries. There are 19 museums, 9 research stations, 3 cultural centers, and a National Zoological Park, a partridge in a pear tree. I throw that in there. We're a builder, owner, operator with challenging funding, and we need to make smart decisions with our capital investment. We have over 150 million artifacts, most of them not on display, with 600 plus or minus buildings that would benefit from having an easily searchable lifecycle database. It'll help us make our decision making when developing our spending plan.
Hello, everybody. At Kaiser Permanente, we are a nonprofit healthcare provider. We're headquarters in Oakland, California. Our facilities spanned 8 regions, from Hawaii to the Mid-Atlantic states. We operate more than 90 million square feet of space for hospitals, medical office buildings, and administrative space. And of course, all these bring some unique facility challenges that sometimes are regional specific, as well as their technological advances that impact and adds complexity to the delivery of healthcare. And so we found that as we developed our programs, that this complexity affected us in terms of our selecting the right life cycle process for moving forward with our programs. Our facility life cycle, unlike other organizations, really 3 phases. And as a nonprofit entity, we reinvest our earnings into our organization's operations. A healthy percentage of our capital is reinvested, and that build-fix decision becomes increasingly complex as we try to preserve and extend the life cycle of our pretty large facility footprint. As we are also reinvesting in building new facilities, we're also reinvesting into our existing infrastructure in the facilities to meet these emerging factors that influence the outcome of functionality, readiness, brand enhancement, and cost. We're committed to factoring consumer preferences and expectations, work styles of our clinicians, and obviously we play a good role as corporate citizens as it relates to all aspects of the environment. One of the challenges that we have in our industry is that our business cases that are used to develop the capital cost and the program cost for each of our projects rarely takes into consideration the overall life cycle cost. There is, without question, a need for a more robust, quantitative, and perhaps qualitative message to support the wide range of decisions that are required by the decision makers that support this investment.
Okay, thank you, Mike. So we'll just do a quick review of the resources, and we'll start our review with standards. So as you may well know, a standard is a document that was developed through an expert stakeholder process within a standards development organization. All of the facility lifecycle value analysis standards that were developed through this process, such as ASTM and ISO, address only the economic dimension of the triple bottom line. So these numbers on the table represent the frequency of those resources. The lifecycle guidelines typically define processes and procedures for the application of lifecycle principles to facilities. And these could be within a specific geographical region or within an organization. These guidelines are generally limited in their scope and application. And it's clear here that the majority of guidelines are focused on that economic dimension, but we do see several governmental agencies and institutions that have included the consideration of occupant and environmental dimensions within their life cycle cost policies and guidelines. Accurate data on costs, benefits, and environmental impacts are required for assessing the life cycle and service life of facilities. Robust data sources provide confidence in results such that they can be used for decision making. These data sources can either be commercial or proprietary. We can see from the frequency that the majority of these data sources are focused on the economic dimension, but we do see a few data sources that include the occupant and environmental dimensions. And finally, software tools. Software tools for lifecycle value analysis are a mix of spreadsheets, web-based, online tools, or standalone applications. State and local governments in particular have developed life cycle cost spreadsheet tools for facilities. And so there are some commercial vendors that have created online life cycle cost tools. Governmental agencies have created and maintained standalone applications for life cycle cost analysis. As we can see here, the majority of those tools are focused on the economic dimension of life cycle value analysis, but we do see a few tools in the occupant and environmental dimension. So let's summarize. Overall, this is the frequency of resources in each of the categories. We see the majority of the resources are in the economic dimension. See that there are few resources that include the occupant side of the triple bottom line. There are several resources that combine both the economic and the environmental dimensions. And the research did not uncover any of resources that include all dimensions of the triple bottom line. So this table sort of represents some of the resources by category. So I'll just go over these really quickly. In terms of economics, we see standards that have been developed through ASTM and ISO for life cycle cost analysis. NIST, or the National Institute of Standards and Technology, publishes Handbook 135, which is a guideline for life cycle cost calculation. RS Means and BCIS, which is the Building Cost Information Service in the UK, provide online data sources for life cycle cost. And NIST has also developed and supports Building Life Cycle Cost, a standalone application for life cycle cost calculation. In terms of economic and occupant, King County, Washington has developed a guideline that incorporates both economic and occupant dimensions, and Carnegie Mellon's Building Investment Decision Support Framework is both a tool and a data source for economic and occupant dimensions, a combined framework. California State University System has developed guidelines for economic and environmental aspects, and NIST has developed BEES, or Building for Economic and Environmental Sustainability, which incorporates both of those dimensions. It's both a data source and a tool. The data is about 230 or over 200 building materials in that database. So let's review the gaps and some recommendations for future research. So the first, we want to start out with the initial gap. The first gap is to really look at developing a standard process that we can use to measure and monetize the economic benefits for occupant health, efficiency, and productivity. And that eventually should be developed through a standards organization. And those consensus standards will help us facilitate the development of guidelines, tools, and data sources. Second, develop some long-term data sources that'll provide empirical cost database that we can use in our analysis. The systematic collection of life cycle data for facilities by organizations will support shared data sources. Next, we need to have tools that include more than just the economic dimension and incorporate occupant benefits and environmental impacts. And lastly, we really need good business cases for better built environments that clearly communicate the benefits of a life cycle value perspective. We feel that these are essential.
Besides our buildings being an important part of our collection, we house 150 million artifacts over 13 million square feet of space. We have strict environmental constraints for managing temperature and humidity, also to support our corporate sustainability goals. All of this makes life cycle information extremely important to the Smithsonian. Smithsonian builds for the long term. We hope to believe 100 years or better. We need to accommodate our changing environment and technology. Having life cycle data will allow us to use our funding better, to better focus on material selections during design, to improve our preventive maintenance and predictive maintenance, our asset management, and reinforce our sustainability goals. Considering that our collections are here all the time and our visitors only are absent one day a year, we're only closed one day a year, Our collection require constantly operating environmental systems. All need life cycle data to help them preserve them for generations to come.
Thanks, Derek. As we look at every milestone in our facility life cycle at Kaiser, we see that it forms the best practice, benchmark methodologies or measures. A decision maker, one who's responsible for making those decisions, I hope, will have easy access to the data. It'll be something that is actionable, something that is believable and meaningful to the industry, while at the same time it's flexible to some of the nuances that are within our company. The research that Dr. Ries has done thus far holds much promise from that standpoint. And we're confident that the elements of this great tool exist, and it's our hope in the next year that we can see some examples how this tool was implemented and benefited the industry. Thank you.
So we just want to cover a little bit about where we're going with our Facilities and Healthcare Committee Life Cycle Costs Phase 2 research project. And this research project will address some of the gaps that we found in Phase 1. The coming year, we'll use some case studies to develop some consensus guidelines, look at some example business cases, and look at the needs for a good life cycle cost tool. We expect to present this work at a future annual conference. And if you're interested in joining the research team, please see us at the booth at the break. We'll be happy to talk to you more about the details of the research and where we're going. Or if you know a colleague within your organization that's interested in this topic, please have them contact us and have them join the research team. At this point, we'd like to recognize the members of the Facility and Healthcare Sector Committee for their support and their contributions to this research. So thank you very much, and we're ready to answer any of your questions. Thank you.
All right. Thank you. Thank you, gentlemen.
Thank you.
We got time for a couple questions, and the first one says, in the context of stage gate project approvals, how to avoid the minimization of the CapEx cost to obtain the FID of the project in this competing environment?
You guys want to take that?
Take that. Yeah.
Okay, so the one with the least business, facility experience, but I mean that's clearly one of the barriers, right? Is to do the CapEx, the capital budgeting, the operation budgeting. Those two things are really always the challenge, and they may not come from the same budgets. So we recognize that. I think it's we've seen it in a number of presentations, both this morning and yesterday, about the importance of optimizing the longer-term performance of the facility, both in terms of cost or schedule. And I think that's an important consideration that has to be recognized by the industry. That's why we're working on some of these business cases. I think that's our approach for addressing that issue.
Yeah, I would just add, too, that, when you know that there's an issue coming on the maintenance side, it's often better to put it on your capital budget so that you can accommodate the what-ifs. Your capital budget can be developed early enough to accommodate the access patterns to get to difficult items that might not be rightful at the end.
Okay. All right, let's go to the next question. Where are your data sources from completed projects, and if not, how many years operation did the data show?
So our scope of our research project was really to identify where the resources were, so not necessarily look at the data within those resources. So that's our next step, is to really look at some of the data for life cycle cost. So we were just doing a survey of the resources. It was a very short-term research project. So that's going to be our next step, is to dig into the data a little bit with some case studies.
All right, last question then. How does the evaluation of the service life of building materials factor into this research?
You go first.
Okay.
I'll back in.
All right. So so service life of materials is obviously critical. And there are models that, that are out there for service life, a number of different types of models that are available for service life. That's an integral part of life cycle cost. And it's not only service life of materials, it's also service life of equipment. Some of the resources, there are some resources that have collected data that are publicly available. I'm particularly thinking of an ASHRAE, mechanical systems database, that's been a shared resources among, heavy users of mechanical equipment. But there's no doubt that there is a significant range that you see that's published for service life, either of materials or equipment. And I think the answer or solution to that is to gather some more data. So whether it's through CII's benchmarking or whether it's another data collection system, we definitely need more robust data sources.
Agree.
And I think predictive maintenance also helps put that into a different ballpark. So you really need to look at that as a big picture, a holistic picture.
Okay. Gentlemen, thank you so much for your presentation.
Thank you.
Let us